We go. All right. So this is the material that we're going to be working with. It's 1/4" mild steel. It's on the surface. You can see we do have a layer of mill scale on here. It's not bad, but with stick welding, we can burn through this. So one of the advantages of stick is with the flux will help burn through this layer, remove it into the slag that we're going to chip off. If we were doing TIG welding, or even MIG welding, by the way, we might want to remove this. I mean, for TIG welding, definitely. MIG welding, maybe. It depends on the process. So we don't have to worry about that today. So how do we get this looking like what we have on the paper? You know, how are we going to do that? So I'm going to take these parts just because it'll help me illustrate what we're doing here. So I got my parts. How am I going to lay it out? So having layout tools is important here. So remember, at a minimum, you want to have a tape measure and some kind of a cheap square. We have some squares in the back we can use and we can share. These, you can use these as well. They're not as good, but they'll work in a pinch. So how do we do the layout here? So I want to get this piece exactly in the middle of this. So how do I want to lay it out is, well, first I'm going to measure and see what I got. So, okay, I got 8 inches on here, 8 inches by 4 inches. This one is 4 by 4. Okay, so I need to find my center. So the first thing, I know for carpenters, it's like, I've done this before a million times. But for those of you who haven't done this, there are a couple of ways you could do this. Now, if I have a square, I could just come across over here and I can just mark it out, you know, and I could take my square over here and I can scribe my line down, just like that. So now I have my center and it is exactly 90, it's 90 degrees to my edge. It is parallel to this edge. This is a really important thing here. As we lay stuff out, we gotta make sure everything is square, perpendicular, and straight. Because if you start off crooked, it's not gonna get any better. So the most important thing here is we wanna start as a high point as possible. So in this part of the build, we take really the most time. The welding out is actually quite fast. This part we're aiming to be as precise as we can, take as much time as we can. Everybody in this industry knows that and will give. They're not going to rush you. They know how critical this is. Because from this point down, everything runs downhill. Okay? Errors compound. Things start moving. Unexpected things happen. You run out of something. Something's not the right part. You know, so it's really kind of like you want to start off the race as well as possible. If you start off down here, it drops even faster. So we really want to take the time on any build, especially when we get to the large final build of the suspended T with the pipes. Layout is going to be critical, and you got to take your time on these things. So, all right, I know my line is straight because I know this is a 90 degree I trust. If you remember going back to Origins of Precision. Yeah. We gotta start with things we trust. We know this square is connected to a chain of trust that goes all the way back to that meter bar in Washington that sets the measurements for everything on this planet. So I can trust this. Everybody I work for knows I work with this, they trust me because I'm working with a tool that can be trusted. So I know this is square, I know this is straight, I'm comfortable here. Now, I'm working on this table right here. Now, if you watch the videos on geometric dimensions and tolerancing, I want to introduce a new concept here, which is called datum surfaces. Now, a datum, which is kind of like what the hell is that? A datum is just like those surfaces that we talked about in the film, you know, something we trust. So I know this table is dead flat and I know it's smooth. So I've got a trusted work surface. So a really critical thing for building is you gotta have a work surface you can trust. You can't like build on the floor. You can't just like build stuff in the air. You gotta have a surface that if I put this up to it, I know I'm dead square. If I put a level up to it here, my level's in here, I know I'm level. So this is it's called a reference surface, okay? A datum is a reference surface. It's something we compare to. So when we're building, well, how do you know that's flat? Well, I built it on this really nice flat table, so I trust it's flat. I know it's flat. So we'll call this our datum surface. Yeah.
So when is the square not trusted if you were to damage it?
Good point. So if I drop this, okay, if I was working, went, boom, and it happens, I dropped it on the floor, I'm like, ooh, how do I check it for squareness? There is an easy way to do this. So if I need to check this for squareness, and I learned this in shop, the first shop I worked at, if I just set this on here like this, I draw a line, I turn my square over, draw another line, these two lines should be dead parallel. So if it does get knocked out of place a little bit, it'll be obvious, okay? It'll be totally obvious something, it's not straight. So that's how I was taught. If you do drop a tool, check it. But if you buy a quality square, like look at me, for right now as students, you can pick up an Empire combination square at Home Depot, it's gonna be fine. But when you become a professional, you want to get something like a Starrett or a Mitsutoyo. It's going to cost you 120, maybe 140, depending on the thing. But because of its trustworthiness, it makes your work better. You see, it makes your quality of your work much higher, and that's important here. I mean, surgeons don't work with, they don't work on the human body on tools they pick up at Harbor Freight. They're custom made to fit their hands for a reason, because it's that critical. We are the same way. So I know I can trust this one. So I know I can trust my table. So we're going to call this table right here, we're going to call this our datum A, if my pen works. It doesn't, so we'll use a pencil. So we're going to call this A, okay, right here. This is datum A. And typically we're going to have datums that be A, B, and C. So I haven't introduced my prints yet, but we will. So think of it this way. Here's A, okay? My flat surface here. And now I'm going to use these other datums to help me build stuff. And I'll show you that in a moment, all right? So I got my line here. Now I want to attach this to it. So how do I get it in the center? So a really fast way that I learned in fabrication was if I mark the ends of this right here, like that. I have a little mark here where that line is, right here. If I take this and I mark the center of it, little red line, or you can just chalk, whatever, like that. And I put it on my surface, I just line up the little dots, dot to dot, and because my piece is now resting on surface A, okay? Look at that, it's dead flat. And now, well, I want to make this better. How can I, well, my parts will fall over, what am I gonna do? So now I'm going to introduce the next one, which is a datum B. Each datum is at a right angle to the other one. Datum B holds this one in place, right here. Now it doesn't go anywhere. So this is B. Now I could have noticed, well, what about this way? All right, let's introduce datum C. Another angle, and now look at my parts. All of my parts are held in 3 axes. So the key here is datum A, B, and C corresponds to A, B, C. 3 axes, and when you think about what we just built, remember the square we were looking at during the midterm? Think of the square. What does the square got? It starts with a corner, A, B, and C. Once you got those 3 axes together, you can build anything. Remember, triangles are most stable form. So A, B, and C, suddenly I can clamp these parts in place and I can tack them out, and I can trust all this because I know here's a nice flat, here's a right angle, here's another right angle, this is straight, this is perpendicular, and my build starts off in a really, really good place. As precise as I can get it, so from this point, as I build and errors start to creep in, I'll end up at a good place within my tolerances. You see that? I'll end up falling within my tolerances. If you start off really sketchy, just throwing stuff together, by the time you're done, you measure, you're gonna be way off. You're gonna be way below your tolerance, way outside your tolerances. So what I learned from looking at that GD&T, what's called the geometric dimensions and tolerancing, which is where this is from, it actually gives us as fabricators a really cool set of tricks. If we think mentally about our work surface and using like blocks or even our squares as these other datum surfaces, if we look at the print and you're gonna see A, B, and C on the print, if we take the A, B, and C on the print, put the A, B, and C on the table, that's our starting point. That gives us start here on the print, like, you know, the corner. And from there, the whole thing just grows. And it's the secret. That's when you look at the print, you're like, where do I begin? There's no starting point yet, but those three axes give us a starting corner. So it's actually really helpful what we're doing. And we're not going to learn a ton of it because it doesn't apply to us a ton, but we have it right here. So here are some simple ones. Could you hand me a piece of soapstone, please? Thank you so much. Thanks. So let's look at just a couple of them that we'll use as welders and fabricators that apply to us. So right here, a simple one is just like this. That. Perpendicularity. I mean, you can see it right here. Either it's perpendicular or it's not. So one of the qualities in GD&T is called perpendicularity. How perpendicular is it compared to my table? It's all about comparison. So I'm comparing it to the table. How perpendicular is it? It looks like that, like welding symbols. It looks like what it's supposed to be. Another one is parallelism. So if we erase this one, parallelism just looks like that. So we could say, well, how parallel is this to the table? Is it laying flat on the table, or is there like something underneath it keeping it from being perpendicular? Does everybody understand that? So simple things to check, like as I'm setting up my workspace, what should I be looking out for here? So, okay, I know I've got good perpendicularity. I mean, with this, I've got good parallelism here. So those are two ones that we'll look at just for right now. I'll be introducing them on prints coming down the road. But if you watch the videos in Module 5, there's a set of 14 videos in there. I know it's a lot. That's why you got some time. Check them out. They're fantastic. And he has wonderful examples like little toy cars and all kinds of models to explain it to us. And if you understand that, it'll give you a tremendous leap above other people that you'll be competing against for jobs. If you know this, your employers will be like, whoa, this guy knows something. This person knows something more than the other person. It's a great advantage for you. So that's an incentive to learn these things. It all translates to money. The more you know, the more money you get paid. That's what's wonderful about this. So, huh?
The employer will pick it up right away.
Yes.
In your language of how you approach it. They'll pick it up right away that you know stuff.
Exactly. And what I'm doing here is I want to show you in laying this out, this is the way it's done. This is the way I was taught. And my first foreman was very, very big on that. He was like, there are ways you do this and there's ways you should follow, and you need to follow that. There's only one, there's only one way, which is the right way, and we do it this way. It's proper practice. It is, it's good form. And when people watch you working like that, a couple of things we talked about before, like, having all your materials within one step of where you're working. Having a welder right where you can reach it easily. Moving efficiently. People see that and they know. I mean, look, athletes do the same thing, right? How many times do athletes practice what they have to do over and over and over to be as efficient as possible, efficient, powerful movement. We do the same thing, efficient and powerful movement. So I like blocks. I have a lot of blocks over in the corner stacked up. The reason I save these is precisely for this. They're great shortcuts. These blocks I know are dead square. These were cut by machine. These are beautiful, perfectly square blocks. So they function like this. I have lots of these at home in my home shop, piles of blocks like this. You may have seen them in some of the videos. They're great for helping when you have to arrange things. They're heavy, holds up, I can clamp to them, they're conductive, I can weld on them if I need to. So now it comes to tacking. So I know my parts are good. I know that I can trust this. So I'm going to start tacking it out. So I got my parts here. So just for the case of fun, I'm going to use this tape in place of tacking because I want to show you something that may not be obvious when we're actually using the machine, but tacking itself is something that we want to be very aware of and really watch what we're doing, okay? So let me take some piece of tape out here. So let's imagine this is a weld, all right? This little piece of tape here. So, because students do stuff like this all the time. So they'll put something here, and they'll be like, oh, well, I'm gonna weld this like right here. And they put their weld on one side, and they tape it down. This is gonna work here, see, like that. You know, I was like, well, I got it in place, it's welded down. But the thing here is, it's suddenly become a hinge. You see that? It's held on one side, and when the metal shrinks, it's gonna pull that way. It can flop around. Okay, same thing happens on the other side. And that's something we don't want, because when we're putting stuff together, this may be very small, and it is, but what if the parts we're welding together are this big, are this thick? You know, and we're talking about many thousands of pounds. You don't want it moving. You do not want moving, especially something like up in the air over you. So we have to make sure it cannot move. One, we want to make sure we're precise. Two, we don't want to risk anything breaking free, because believe me, the first time it happens to you on a job, you'll never forget it. Hearing the sound of tacks breaking strikes terror in the heart of every metal worker in the shop. It's like the scene in a movie where, like, you know, you're in the ship and they can hear like the bulkheads buckling in a submarine movie. It sounds just like that, and really it's a scary sound because you know something's about to break free. So we don't want that to happen. So instead I'm gonna do this. I've got my parts in relationship here. So what I'm gonna do instead is I want to tack on the ends. So I'm gonna tack one right here, like that. And then I'm gonna tack. Tape didn't work out as well as I thought it would. It's doing its job, being sticky. So once I have this one down over here on this side, okay? This allows me to check, correct anything that's crooked like that, okay? I can correct over here, and then I'm gonna put another tack on this side over here, like that, this way. My tacks are here and here on the ends. This allows me a completely uninterrupted run where I want the weld to go. If I've got tacks over here, now suddenly I've got like almost like speed bumps I have to go over. I mean, welding go blonk, blonk, and that's gonna cause a lot of problems. So when you're tacking, you want to tack in such a way that it's not going to interrupt what you're doing later on in the process. So there's a lot of thinking that's involved here. We have to plan our moves ahead. Tacking here frees up my area, so I have a nice smooth weld here. It's tacked over here, so the weld is pulling this way and this way. It's not pulling over here. The forces are canceling each other out. So my part is actually quite comfortable. It's not pulling in either direction. If I have to break it free, it's easy enough to come in with a grinder and just go chit, slit one and break it right off. Very, very easy. If you have a tack in here, suddenly it could get very, very, very difficult. You may not be able to get a grinder in there. If it's a situation like this, where I've got another piece in place, there is no way you're getting a cutting tool in there. And this is actually what the situation that will be set up in the suspended T. If you goof up tacking that thing, there's no recovery. It's a one-way welding process. So we want to think ahead. I want to tack this in such a way that if I have to remove it, I can. You always want to think in the mind when you're tacking, if I have to take this thing apart, I need to be able to do that. So the process we're going to do is, wherever we build is, we're going to be tacking the entire thing together first. Then we're going to check every single measurement, make sure it's within tolerance. If it is, next step is we're going to fix it so it can't move, which means I might add bracing to it, I may clamp it down. And when it's all said and done, then we're going to proceed with welding it out. When we're done welding it out, we measure it again. Check it against the print and see how far off we are. If it's within tolerance, we have a good part. If it's not within tolerance, we need to figure out why. And then go back in our process and examine where do we go wrong, you know? So it is a lengthy process. I know for a lot of you, it's like, oh, I'm gonna get to the welding part. Yes, but we gotta do the groundwork first. This is the part that really separates the quality craft people from hackers. And you don't want to be called a hacker. What you call a hacker, that's like, you know, goodbye, good luck, you're doomed, you know. So this is the quality work. So now I've got my part out. Now I can, you know, I like to do stuff like, I may like leave it clamped on here so I can weld it out fixed to some parts that can keep it from moving. I can do this, like that. So I could clamp it here, weld one side, move over here, weld the other side. And you know, it makes the job much easier. Now in this case, we're going to be welding it in this position, okay? So we're gonna be welding in the fixed position and we're gonna be doing horizontal welds. So once you're done tacking on the table, next step is to weld a small tail on the back, a piece of scrap metal that we can put into the clamp and raise this to a comfortable height. Doesn't have to be overhead, doesn't have to be over here, okay? Just somewhere comfortable. Comfortable means you don't, you know, you don't want to be like this. You want to be where your arms and shoulders are relaxed. So you can weld, you know, and you're not chicken wing like this, you're comfortable. And if it's not, move the work. Always adjust the work to fit you. It should never be a case where you are adjusting your body to the work. That leads to injury. Never. Always adjust the work to fit you. Whatever you gotta do, you gotta get a ladder, you have to get a step stool, you have to raise the work up, you have to build a platform to get to it. Always do that. Never put yourself into a position where you've got to overextend your body, get into a weird position, because it may be okay for the moment, but these things over a long work life will cause chronic, irreversible injury. And if you can't work, we can't make money. So we always got to keep that in mind. You know, you never want to be in a position where because of your injuries, you can't play with your kids. You never want that. You know, hey dad, come on. And you're like, I can't run that fast, you know. Catch the ball. Yeah. You know, I can't lift my arm over my head. You don't want that. So we always want to think what's valuable and what's right. So always fit the work to the worker, okay? Never the worker to the work. That's an important thing. Be wary of employers that don't think that way. I had a student come up to me yesterday after graduation who talked about that. And Carol and I said, you know what, don't even go back, just quit. Don't go there because you're gonna get hurt. These people don't care about you. They don't care about the welfare of the workers. Walk away. There are better people out there.
What did they want him to do? This welding?
The place was a death trap. It was a mess.
It
was a mess.
Was that the weld that you posted online?
No. This is some other place. But just the place was not a comfortable. The place was not a healthy workplace. You don't want to work there. All right, so let's get laying this thing out. So let's get some metal and let's tack it together. Let's do the thing for real. Okay, so here's our practice. Let's do it for real. So here's my metal. Here we go. So I'm gonna lay it out. So I've got another pencil. I'll leave these here so we can use them if anybody wants to. So what we're gonna do here is a little different from the print. I changed something. What I wanna do here is we're going to set this up. We're only gonna weld halfway on this, okay? We're gonna weld halfway down. We're not gonna do the whole plate. We're gonna use this for a couple of different things here. So this is part one of like a 3-part thing we're gonna be doing over the next few weeks. Okay, so I got my plate. I'm gonna measure it just to see what I've got. You can use a tape measure too if you have one. So I got 6 inches, it's good. The CNC cut it, so I know it's a perfect 6-inch square, which is great. Have a human being cut by hand, I would be very careful about that. Luckily we have a CNC machine, so that makes our lives fun. So I'm gonna mark it out. Now, when I marked it out, can you see I marked it out with like little, almost like little arrowheads? Everybody see that? So, do you use this in carpentry? Okay, so this is the right way to mark out your measurements. Don't do a straight line, okay? Don't do that. What you want to do is do a little arrowhead that points to the line on your tape measure or your square. The reason is a point is of infinite thinness, okay? If you do a line, you know, which side of the line is it? You know, if you do chalk, you know, if you do a chalk line, that's a big fat line. Where inside that is my starting point. But if you do either a scribe line or with a pencil, an arrowhead, it comes with infinite points. And you can point to a very, very precise spot. This is the way fabricators lay stuff out. This is the way I was taught. So now I know where my line is. So I can take my square, I can put it up against here, and I can scribe out my line, and I can get my halfway point on here. But let's say you don't have a square. How can I use my tape measure to do the same thing? So I can take my tape measure, I can mark out my 3-inch spot, then taking your same tape measure, put it on the edge, you know, and then you can tilt it a little bit, line up the edge of the blade, a metal one, with those same arrowheads, and you can put your line down. So you can use a tape measure. This is common from the world of carpentry, and it works the same for metal, and that works well. So you can do very straight lines with this. I mean, I've done 8-foot ones with this. Have one person hold it and pull it tight, and then you run carefully, you can run right along the edge. So you can mark out perfectly square, parallel, perpendicular lines with just a tape measure if you don't have a square, or you have to do a really big measurement. This will help you. I used to have one that was 50 feet long. I have a 100-foot one at home. So for structural, sometimes we have to lay out some very, very large things. So there's a little baby one. So I got my line. Okay, I'm happy, I got my line. Now I got my metal. And I'm just gonna eyeball my center here because it's only a 1/4 inch, so it's pretty easy to lay out the center of a 1/4 inch. So I'm gonna lay it on here. I'm gonna butt it up against my B right here. This keeps it square here, square here. So now I don't have to think about it. I know these two plates are gonna be dead square to each other and in the same plane. Then this one here, right there, I'll just line it up with my mark right there, right here, butt it up against this right there. And now I know I'm exactly where I need to be, right on the mark. Boom. And if I want to make this even better, got my clamps. So clamps are essential and really useful. I say, well, we have magnets too. Why wouldn't I use a magnet? Magnets are as harmful and really injurious to laying stuff out as they are helpful. Because one of the things that you will discover is the plasma that we're welding with is electromagnetic energy. It's attracted to magnets. So if you have a big magnet on here, when you're welding, you're gonna see your plasma flame go right to the magnet. So if you have a big magnet near where you're welding, you're gonna see some very strange things happening, and very often students forget this. So they'll have magnets holding everything together, then when they strike the arc, it suddenly goes crazy. That's what we call arc blow. So I think one of the modules has a video on arc blow that I think I posted already. If you haven't seen it, go back in the weekly units and watch the video. It shows you beautiful film of very strong magnetic fields near welding arcs, and it's pretty eye-opening. It is a problem in stick welding. It's a horrible issue in TIG welding, and you'll see that when we get to that point, because it's very delicate and very subject to magnetic fields moving it around. So now I know this is not going anywhere. I like that. So let's tack it together. So I'm gonna get my machine lit up, get my gloves on. So I could use these gloves, your standard heavyweight gloves. I actually prefer these ones, the MIG gloves myself, because I have a little more dexterity with them. I think they fit better, and I like the hand pad to keep the back of my knuckles from getting roasted. So very comfortable. Yeah. So now I'm gonna tack it together. So for tacking, we want to use a tack rod. So we're gonna use a 6011. 7018 is for welding out. 7018 is very temperamental to tack weld with, because it, as you've probably discovered, it likes to either stick or it doesn't ignite unless you clean off the end. The 6011 is a tack rod. It'll go as soon as you touch the metal, boom, it's right there. So for tacking, we use this, because this way I can quickly tack parts together without having to go rub the end off, look at the end, wondering what's going on, and waste time. 6011, yeah. Now 6010 is functionally the same rod. The difference is one is an AC/DC rod, the other one is AC only. We don't need to worry about that, but if you do see a 6010 in there, it's the same thing. They're supposed to be exactly the same. Both aggressive tack rods. So set the machine to on. Now this is an 1/8 inch rod, so I can set this to 125. This is a 1/4 inch material. Set this to maybe 100, because I don't want to burn through it like crazy. Okay. So we're good. We're good.
Oh, I thought they were just laying on top. I didn't realize that.
Yeah, it's clamped. So I got my ground clamp is on. Remember, my ground clamp is in the direction I'm welding. So I'm welding here, my ground clamp is there. So always try and have your clamp in the direction you're welding. So if you're changing direction, you may want to change your clamp. You want to move that. So if we're welding up here, I may want my ground clamp here, not down there. Because if I'm welding over here, I don't want my current going away in the opposite direction for where I'm welding. So move it accordingly. You'll see better performance. Okay, so what we do is we're going to yell cover. And here we go. So cover, and I'm going to just tack it. And that's that. So we got a little tack on there. Take your rod out when you're putting your stinger down so it doesn't ignite all over the table. So I'm going to take it out. The blocks. And first thing you want to do is I want to check this and make sure that it's actually straight. Because things are going to move on you. We know metal moves when it gets hot. So I want to check this and see just where am I. Looks good. I like that. That looks nice. It's a little bit off over here, so I notice it's a little leaning a little bit that way. It's a little bit off. So what I'm going to do is I'm going to tack the other side, and that'll allow me to tap it with a hammer a tiny little bit and bring it back to perpendicularity. So I'm going to tack weld the other side right here. Cover. Small tack, it doesn't have to be crazy. Generally go like 1, 2, 3, like 3 seconds. You know, it doesn't have to be crazy here. I gotta make sure I can take this off. If somebody comes running through the door and says, it's the wrong part, take that weld apart, you gotta be able to do it. You don't wanna go, oh man, it's all welded out. You wanna make sure you can reverse it. So, now I know I'm not dead perpendicular, I need to fix this thing. So, I'm going to move it that way. So to move it that way, first things first, let's clamp it down. Because if I have this just sitting here and I bang on it, it's gonna go flying over the table. So I need to fix this thing down so that I know it's gonna stay where it's put. So when you're working on stuff, always keep that in mind. Where's the force going to go? It's gonna go somewhere.
Yeah, you're gonna tap that while it's still semi-warm, right?
Yes, yeah, if you can, yeah, if possible, you want to whack on things when they're a little on the warm side. And so I need to go that way. Perfect. And that's that. So now I know my plate is flat on this plane because it was touching against my B datum block. So I know this face is flat. I know my bottom is flat. I know this is perpendicular because I had it clamped to this perpendicular block, my datum C. I checked it with my square and I corrected it. I like what I see. I said, all right, I can begin. I think this is pretty cool. I'm ready to start here. So my part is ready to go. Now, before we begin, we want to remember things from how we start our arc. So on this, we want to go just halfway down on here for this thing. Okay, we're not going to do the whole plate. We're going to go with halfway, all right? So before we begin, let's lay it out. Get some chalk, some soapstone, and actually lay out your guidelines. Like, how far down do I need to go? And, you know, actually put a border down there so I know where to stop. Okay, I'm just gonna eyeball this just for the sake of time constraints. Here, so I got my line down. 1, then I go this direction. 2, and this way I can move a measurement around the surface. 4. So now I've got my line moving around the right angle.
So it's like a quarter inch, a quarter inch of line. That's like the way the first weld's gonna be.
Well, your weld's gonna start up top here. This is your end point, okay? So when we weld this, we want to start, what we're gonna do here is, we're going to start here, weld across, go across the corner, and finish over here. And then on this side, we're gonna start over here, weld this way, and finish over here. So, yes. So you're gonna be welding this way on this side, and this way on this side. So we're gonna start off left and right side. I know people are like, whoa! Yes, because it's a necessary skill we need to develop. So, and also because it's gonna show you something. Like, coming from the world of like athletics, it's amazing. It's amazing to realize, like, wow, I can kick really well on the right side of my body, but then the left side of my body I can't. And you're like, ooh, that because my muscles are not as developed on that side. I need to develop those things. This is going to show you what you need to develop, and you're going to see what you got to work on. And a lot of it's just muscle, like learning to move the muscles on this side of your body as well as on the other side of your body. We want to be balanced so you can weld with both hands. One, because sometimes we gotta move that way, but what's if you get injured? You know, I've seen people bash their hands with a hammer and then they're like, well, I have to weld with my left hand for the next couple of weeks. You may need to do that. So we wanna be functional on both sides of our body. It's important for our work. Now, I would recommend, because I notice a lot of you, it can be really hard to run that bead straight. I know, it's hard. You're looking through the helmet, it's like, I can't see anything, what am I gonna do? Take your chalk and using your ruler or square or something, give yourself like a straight line to follow. Lay out some lines on there and then practice following those lines, okay? Follow those lines on there. It's okay, you can do that. I've done that, that's perfectly fine. You don't want to be welding all over the place. Your lines should be exactly parallel to the edge. Parallelism. Your welds need to be dead parallel to the edge of your plate, perpendicular to this edge of the plate. Like think of Venetian blinds, just like that. It's gonna be tricky, but we can do it. So I got my plate, now I want to put the tail on it and get it welded up. So let's grab a piece of scrap metal from the bin. Right here, this will do. That thing. Now, we're going to be using the back face of this for subsequent exercises. So this is a part. The back is not just for practice. This back part we're not touching right now. We're going to use this for something. So we want to preserve this. This is an important part here. Do a bunch of fun stuff with it. So we just want to tack this tail to the back. We want to be able to remove it. So with that in mind, I'm actually going to tack this on one side only, so that later on I can snap it off easily. Okay? An important principle of welds is this, and I'll demonstrate with this part right here. So if you would, all right, cover. I'm going to weld this to the surface. I want to show you a very important idea. If you've never seen it before, this is a critical one. So cover. Here we go. All right. So this is a 6011. So how strong is this? What's the tensile strength of this rod?
60,000.
60,000 pounds, right? That's a lot, correct?
Yes.
Okay, so I got a weld down here. It's like, whoa. So it supports a lot of weight. 60,000 pounds, ladies and gentlemen. It's very, very strong. Yet, if, could you have that wrench over there, please? Yes, thank you so much. That one right there, perfect. Very strong in this direction. Yet, if I just do this, I can break it right off with very little pressure. So a really critically important thing to keep in mind is, okay, welds are very weak from the backside, okay? All the strength is on the fillet side or groove side. The backside of the weld is extremely fragile, okay? A great illustration of this is you've probably seen demonstrations where they'll park like a garbage truck wheels on like 4 eggs. I've seen photographs, you can look up photographs of this. The strength of eggshells is ridiculous, okay? They put a truck on like 4 wheels on 4 eggshells, yet it's weak enough from the inside for a chick to break through. Welds are the same way. There's massive strength from the outside, but from the inside, stunningly little. So think about this when you're tacking stuff up, okay? You gotta make sure your weld is in the right direction for the force applied.
If you had to weld that all around all 4 corners, it would be hard to get off.
I would not be able to get it off without cutting it at all. Yet, I can tack it, yeah, this is gonna hold, but I'm able to break it free, okay? So if I had something hanging here like this, I could tack it from this side up here, pulling in the direction of the weld. It would not go anywhere. If I weld it on the bottom, however, boom, it would come flying right down. So think about the direction you're welding stuff. You gotta keep that in mind. So when we're welding up that very, very, very heavy thing we're gonna be doing, you better make sure you put the tack in the right place. If you tack in the wrong place and suddenly your partner lets go, you're gonna have 50 pounds of metal come crashing right down. And that happened a couple times during class. You wouldn't believe the noise it makes when it hits the table. It's just like, ah! So welds are back-breaking welds is very easy. It's a cool trick to know, but know where the welds are. It's no strength from the backside at all. Great strength from the front side, nothing from the back side. See, the same thing is true with 7018. Doesn't matter how strong the weld rod is, it's physics. So when I tack this up, I'm gonna keep that in mind. So since all my force is going down, I can put my tack on the top side because all my force is hanging down this way. It's like hanging a picture on the wall. All right, so I'm gonna take this. And I'm gonna tack it in place. Okay, so cover everyone. So I got my part in place, and now this is gonna stay right where I put it, but later I can bend it the other way and it's going to come right off with very little effort and not a lot of drama. So against gravity, this works beautifully. It's not gonna go anywhere. So I can put it here and put one tack here and cantilever. It's called a cantilever. Cantilever this way against here, and it stays exactly where I want it to go, and it's not gonna go anywhere. So that'll be the next one. So let's tack it in place. Now, if your booth does have a C-clamp, just use that. This is a demo plate I put together, so it doesn't have a clamp, it just has this one plate here. So I'm gonna put it in place, so I'm gonna put this right here, and weld right there. There we go, all done. Now my part is fixed in place, it's not gonna go anywhere. I'm confident I can build. I think this is pretty good. So now I'm getting serious. So now the next thing is I'm using a 7018 rod. That's what we're going to use to weld it out. I'm actually going to switch glasses. So these are bifocals. These are the cheapo readers I've been telling people about. So if you do wear glasses, bifocals, unfortunately, are great for driving because I can see here and I can see in distance. Bad for welding because you're at a fixed distance. So fixed readers are fantastic for like doing small work and welding and stuff. So you may want to look into it. How to choose? Go to a grocery store where they have these glasses and just try on different ones and make sure you can see about this close is nice and clear. About here, you're good. And I wear these, I put the expensive glasses away, break out these, and now I can weld with great comfort. So, pretty cool. So now I'm gonna get my rods. Oh, they're on the table, not that. Okay. Filming, fantastic. So again, we want to take 3 rods at a time. I'm actually going to move the camera over here. Sure.
You said when you're connected with this back part, you're using clamps.
Yeah. Yeah, we can use, yeah, if we have a clamp, you can use a clamp, yes.
Okay, so how do you put those into the clamp? Like, do you want the clamp facing a certain way so that the leads really distribute it?
Let me get this in here. Huh? I think I can adjust it. Let me adjust it here. I think it's good. Oh, I'm good. Okay, fantastic. Okay, so yeah, the clamp will be able to grab onto this thing. When you'll see it's a C-clamp, so just clamp onto here and you're good to go. Yeah, just clamp right onto there. Yeah, and you're fine. So now I'm ready to weld. So I'm going to set my workspace. So I'm going to get my precision tools out of the way because these are going to have all kinds of stuff falling down on them. So I'm going to get this out of the way. I have my chipping hammer. I'm going to block this out of the way. These out of the way and I'm done with them. Could somebody with a brush, perhaps? Cleaning brush? Thank you, got one. Cleaning brush. So since I'm welding up in the air, I'm gonna move my clamp up here. Now I can move it like right onto the workpiece if I want to. So maybe I'll do that. But you want your ground as close to your work area as possible. You don't want your clamp 20 feet away. You will notice a drop in the strength of your arc. There is what we call line loss. You're going to lose some of the power with distance. When it's close as possible, it keeps your arc right through here, right to there. Okay. So I want to describe out a couple of things here. So if you remember when we lay out the beads, we want to start our arc about about a ½ inch in on the plate, okay? So I'm gonna put a line on there just to give me a visual reference. I'm gonna strike here, go to the edge, and then go the rest of my way through. We don't want to start at the edge for a couple of reasons. One, we're not permitted arc strikes. What it means is, if you come in here like all over the plate, arc strikes are injuries to the test material and are qualified as a failing thing. If they're big, it can invalidate your test plate. So when we get to doing the AWS D1.1 bend testing, if you have arc strikes on your test plate, we will not test it. It invalidates it. So what you want to do is I want to weld over it. So if I strike here, go to the edge, I'm welding over my arc strike and covering it. No one will see it. Second reason is the rods and the plate take a little bit of time to heat up the temperature, and you'll notice that. This gives time for my arc for my rod here, my arc to strengthen. So when I go to start my weld with a good, strong arc, I can lay down a really nice bead. If you just start welding, so it's cold and then it warms up. So it kind of tapers, and you don't want that. You want a good bead from the beginning. We want to weld from this edge all the way to this edge, a full length bead, okay, from edge to edge. So that's a 6-inch run, 3 here and 3 here. A 6-inch weld bead. Well, there's a problem here. If you remember, the sheet I gave you says you may not start or stop on the corner. That's a universal rule for structural welding. We want to get in the habit of this. We're going to be doing this with TIG welding as well. So if I'm welding, I can't stop in the corner and then start up again. You may not do that. The reason is you're going to be forming like almost like a joint, a crack. That will fail under stress. You need to weld through a corner. So we need to plan our attack very carefully, okay? So if I'm welding, and I know, say if I'm welding with a stub rod, a shorter, a little stubby rod, like any one of these two, okay? And I'm like, okay, I'm gonna run out of rod in that corner. Well, maybe you should choose a different one. Plan it so that maybe I'll stop here, like halfway across, tie in there, and then go the rest of the way through. So we need to think strategy. Okay, I want you to look at the rods here. Remember, you only get about 6 inches out of this thing. This is 6 inches. So you know you're going to run out of rods somewhere. So we need to think carefully. That's why all the stuffed rods in that can are there. You're going to need some small bits and pieces. It may be more strategic to string together a bunch of smaller welds than try and do it all in one go. And that's a very important lesson here for us. Don't try and bite off too much. It may be easier to do small tie-ins rather than, oh, I can make them agree. You're like, oop, I ran out. Ugh. So I want you to think strategy here and really think about how I'm going to space my things out. So that's an important idea here, yeah.
How close can you be to the corner when you stop? Like if you're
To there?
short. Yeah, so without...
You can be right on it.
Okay.
When you get to a corner, what you want to do is get to the corner and then be like 1, 2, 3, and then flick out very, very quickly. You want to give a little extra metal on the corners, on the ends when you stop the weld. Give yourself a little more, it can end up like a little bump. That's perfectly okay. You want to make sure that we don't end with too little metal. It'll form something called a crater crack. You don't want to end with a crater because that's a weak spot. So we want to give a little extra metal at the end weld. So I'll do that running. I'll just do one pass through here. Before I begin, I'll just quickly. Yeah. I'm going to start with 70-18. Now tack, we want to do this with 70-18. I did my tacking with 60-10. So I'm done with the 60-10s. Now I'm going to go on to the 70-18s. So these are, huh? Yeah, I'm going to do both sides, yes. As well as I can, folks, I'm going to do both sides because we all have to. So this is a 3/32 rod, and if I check my thickness here, Emerson gave me this funky little gauge here on Harbor Freight in home, are really fantastic. So here, my measurement is 9.099. So I I know that I need about 99 amps or so. Actually, it should be about 95. I mean, that's a little sketchy. It's usually these come out to actually 0.093 is 3/32. So my minimum size is going to be 93 amps for my power. Now, remember, that's just middle, okay? That's just middle. We're doing a horizontal weld, so I may want to do a little bit less. I don't know yet. So I'm going to start at 95 and hope for the best. I know this thing can do. Where's the date setting? Where's the arc force setting on this thing? Do you remember which button it is? I want to turn that thing. Ah, there we go. We want to turn it on. My arc force up to, I don't know, do 2? No, 3. Let's do 3. So I'm going to use arc force on this. So if you have the two B275s, arc force, give yourself like +3 or something. We want to use it as a tool here. Arc force is going to drive the arc into the surface and prevent sticking. So if it's there, why not use it? Okay, if you have one of the C300s, Ryan can show you where it is. If you have the Dynasty, that's in a different location. The blue welder will show you where that is. If it's there, people will use it, right? There's no sense in welding out. It's not cheating. It's using the tool that's meant to be used. So I turn my 3, give us a little more force in there. All right. Get this out of the way. Let's go ahead and spatter and run down. This body position. So I want to be comfortable, so I can brace my hip against the table. I'm borrowing stability from stuff around me. So I'm leaning against here. I want my arms to be comfortable. I don't want to be up here like this. I want to be comfortable. Now this is different for everybody, but I want to be stable. I'm going to be able to get in here and then change direction and come across this way. Okay, we want to move in a smooth movement. So I want to weld across, come into the corner, and then change direction, come around this way. I'll do my best. I haven't done this in a while. So, but you know what? Challenges are good for us, and we'll learn a lot. So here we go. I want to be parallel to my top edge. I want it to be good. Here we go. Cover everyone. There we go. So, light up in the corner. There we go. Bring it over. Looks pretty good. You can't lay as much metal horizontally as you can flat, people. Don't even try it. It's my corner. Change direction. So I move smoothly through my corner. I don't want to stop in the corner. So we take a look at it. What does the chip is? So when you're chipping, wait for your plate to cool down. Don't rush. Never chip it when it's still blowing. There's always like, I want to see what's on it. Wait. And as the plate gets hot, it's going to take longer to cool down. Some of the students have noticed something, which is that when you're welding on the table, it's like you can weld a lot. And then you bring something in the air so you can realize, like, wow, why is that plate melting so quickly? Remember, this is a massive heat sink, okay? All that extra energy is going to this table, or the tabletop in your booth. Here, there's nothing for this heat to go to. So it's going to build up a lot. So you want to be very careful about that. When you start seeing your bead getting out of control, you want to, all right, I'm going to put it in drink water, go for a walk, let it cool down. Now, realistically, how can we deal with this if we were working professionally? And like, what am I going to do? You may take a massive piece of aluminum and collect it on the backside of your weld as a heat sink. There's such a way that it's a heat. When you get to TIG welding, this is the common practice for us. We'll use heat sinks strategically, what they call chill bars or backing blocks, to function almost like metal ice cubes, to suck away excess heat. You may notice that here. So if you notice that, I've got lots of blocks in the last group of it. You may want to try clamping one on because the heat is going to build up and it's going to be very difficult to deal with. Now, our strategies, I'll show you to deal with that. Something called backstitching. Oh, backstitch welding. I'll show you that later on. The strategy. So backstitch weld in a case where I'm welding up here, like I'm welding this plate, I can weld, say, vertical, and like the heat is going up and I'm going up. Backstitch welding means instead of welding on one end up this way where the heat is going, I'll weld like this and start a third of the way down and go up, 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 so that when the heat goes this way, I'm going that way. So I'm actually welding towards the colder part of the plate every time. So we'll practice that later on. Yeah. So let's see what it looks like. So I'm going to chip it off carefully. Looks pretty good. So the weld looks pretty good. It's got a nice gentle crown on it, so it's not too big or too small. Crown looks good. It's a little hot on this side, which is interesting. It's nice and flat here, but a little hotter there. So I could lower the temperature a little bit, but I think it's alright. So let's go over here and do this side now. So now I'm welding with my I'm welding like my offhand side. So I'm a couple of strategies here. Oh yeah. Okay. So a couple of strategies here. I could weld like this. Remember, I'm starting right and going left this way. Now I could weld like this, like everything all ramped up. I could switch hands and go left hand down with this side. So I'm mirroring exactly what I'm doing on that side. Here I do right hand dominant. Here I do left hand dominant. I'm going to try left hand dominant. I suggest for you too, mirror both sides just to get used to how complicated it can be, because when we get to doing the 5F weld, you're going to have to go left side and right side. You're going to have to figure out, how do I do the left side of the pipe and the right side of the pipe? Everybody right-handed crashes and burns on the left-hand side of the pipe. Everybody left-handed crashes on the right side of the pipe. So clearly we're not balancing our welds somehow. So that's what we're looking at here. How do we address that? How do we fix it? Here we go. So check your floor, make sure you're not stepping those cables, you want to wrap around your foot, step and fall. Move this out of the way so you burn it. Alright, this should be good. Here we go. Stable. Alright, just have to think about this a little bit. Oh, left hand down. Left hand down. Oops, sorry. Left hand down. Alright, here we go. This is very weird. Alright, so I killed it right past the corner, but I didn't get the corner, so I'm through the corner now. So okay, I didn't stop at the corner, it's close. So I'm going to let it through it, chip it off, and then find it. No, I think his heat's okay, so I think his heat's alright. I didn't want to lower it and afraid of it. I think it's just right for now. Okay, so now it's high and we continue going. Alright. Ready, cover. So the way to tie it is you want to start, when you tie it, you want to start like, use my weld, start over here, light it, bring it to your weld, and then go. Just like you're starting a weld. Start a little bit away from it, bring the weld, the plasma on the weld, and then continue. Right through. So weld looks like it come out okay, so I'm happy with it. So what we want to do is continue this down to halfway. So you want to remember you want to overlap those welds nice and tight, halfway down. Don't go beyond half because there's something else we're going to do here. Bring it down halfway. Yes.
Talk a little bit about the focus of basically the rod in relation to the piece.
Sure.
And
Yes.
then, you know, both in relation to the piece, but then elevation, because I'm sure.
Yes, exactly. So what I'm doing here is your rod should be maybe about 5 degrees called push angle. It can be dead straight to about 5 degrees or so, maybe, you know, roughly, maybe a little more, maybe a little less. But you want to have it fairly, you don't want to have it like that. You don't want to have it eating down. Because remember, gravity is going to be pulling your weld metal down this way. So we need to counter that by aiming up a little bit. So the metal is going to be liquid, drop a little bit, and then be in place, okay? So I'm dragging a little bit, and since if I'm going this direction, I'm going to drag angle about 5 degrees or so, not very much. Though by the book, your drag angle could really be as much as like, I think 26 degrees if you wanted to. A lot of that has to do with technique, okay? I mean, I've seen people weld like that, really flat. So you can do it, but you have to kind of like understand how to juggle all of your parameters. Like those 5 parameters, that colored diagram I put up, you have to know how to juggle those 5 different parts to get the weld down. So as you get more experience, you'll be able to monkey with those a bit until you can lay welds down with some pretty strange angles. So I'm dragging a little bit about that. When I reach the corner, see if I drag too much, I'm going to bump into this. So I have to come in here and then very quickly just suddenly tip across the corner. It means body position. So I got to move my body. And I want to move my body. I don't want to just move my arms, okay? Don't just move your arms. Your hips and your shoulders should be a solid unit. When you're welding, you should always move as a solid unit. You never want to do this, because if you move with just your body like that, your welds end up doing a dive. Some of you may have seen that when you're running straight bead. It feels like, where's that curve coming from? Because you're rotating from your hip, and you inscribe a circle. You see that? I'm inscribing a circle. I'm not inscribing a straight line. So you have to move your body as a continuous unit. So that means using your feet, stepping into the motion and going across. What? It's true. It's like
I have a hard
dancing.
time doing what you say.
It's like dancing. You have to master the footwork. You have that, here, and here. Simple. I'm just stepping one step into it, just like that.
I tend to just keep the arms.
It's very natural to do that, but it ends up, you end up seeing a fall off at the end of your weld. It's just kind of like, it droops like, and you weld, and you look and you're like, why is it doing that? When we saw this last semester, students were like, absolutely baffled why their welds kept falling at the end, curved, and when they looked at their body movement, it was like, aha, I didn't realize I was doing that. And vertical welding, they go like this, so you're welding when all of a sudden the end it goes zzz, as it arcs out because you're doing this. So you're pulling the rod away as you go up. Your arc extends and you get this huge plasma blow melting everything. So this is our horizontal T exercise. So grab your material, you can get squares, get some chalk, or some pencils there. Grab a booth, lay yourself out, take your time, and Brian and I will be here to help you get it all together. So let's get welding, everybody. Let's have some fun.